A functional flow block diagram, also known as FFBD, has the classic features of logic structures. It is available for entities in the function class, as well as any other subclasses of processing unit. Part of the behavioral representation set, the FFBD unambiguously represents the logical flow through sequencing of functions and constructs. It focuses exclusively on structural control and ignores the sequencing and synchronization aspects of the corresponding data flow. The enhanced functional flow block diagram, or EFFBD, is the most complete representation of behavior. It includes all of the flow and sequencing information from the FFBD, as well as the data interactions overlaid to present a more complete picture. The EFFBD also displays resources, the third critical aspect of executable behavior. On the diagram, rectangular nodes represent functions. The flow of control is left to right by default, but can be changed to show the flow from top to bottom by selecting the vertical layout option from the ribbon. We recommend setting your preferred layout before moving nodes and editing the diagram. Circular nodes and branching structures represent control constructs, the building blocks of behavior. As a function completes execution, flow of control proceeds along the branch lines to the next function or control construct. Reference nodes are a special aspect of FFBD and EFFBD representations in GENESYS. Reference nodes reflect the context immediately surrounding this behavior and can be toggled on or off in the Properties tab of the toolbox. The function shown in a gray box with a broken frame on the left edge represents the last function to complete before this decomposition begins, the source of control flow. The function shown in a gray box with a broken frame on the right edge represents the next function to enable when this decomposition completes, the sink of control flow. When there is no previous or next function, the boxes are simply labeled ref. These reference nodes are automatically computed and updated by GENESYS and provide very valuable context information. Items passed between functions are represented by rectangles with a more rounded edge. Triggers look a lot like items, but to distinguish them between data stores, GENESYS color codes the triggers green by default. Resources are also shown on the EFFBD and are represented similarly to an item node, but with a double border. Reference nodes, data stores, and resource nodes can be toggled on or off in the Preferences under the Application menu or in the Properties tab of the toolbox. Another essential part of the EFFBD is the control constructs. There are a number of them that can be used. To add a construct to a diagram, simply click and drag the construct name from the Insert tab in the toolbox. Let's take a moment to go over the different constructs available. First is the AND construct, also known as a concurrency or parallel construct. The AND node is followed by separate branches that rejoin and terminate at another corresponding AND node. The construct designates that all branches execute simultaneously. All branches must complete before execution can exit the construct. The OR construct is also called a select construct. When execution reaches this construct, one of the branches is chosen and executed. None of the other branches are executed. Each branch can be assigned a selection probability using the right-click menu. A multi-exit construct, also known as exit condition, is a construct where multiple branches exit from a function and rejoin at an OR node. This operates similarly to an OR construct where only one of the branches is executed. When an exit node is encountered, the rest of the diagram is skipped and execution will move to the sync reference block. A loop construct consists of a pair of loop nodes that enclose a branch and are connected with a loop back line. Everything between the loops will be repeatedly executed in sequence. A loop is usually accompanied by a loop exit, which provides the mechanism for exiting a loop. Without an exit, the loop continuously executes. When a loop exit is encountered, the innermost loop is immediately terminated, enabling the construct or function following the loop. An iterate construct consists of a pair of nodes that enclose a branch and are connected by a loop back line. The line is automatically labeled with the name of the associated domain set. Everything between the iterates will be executed in sequence the number of times defined by the domain set count attribute. The replicate construct is made up of a pair of nodes that enclose a main branch and are connected with a coordination branch. The coordination branch is automatically labeled with the name of the associated domain set. This construct is a shorthand notation for identical processes that operate in parallel. All of the constructs that we have defined are used in both the FFBD and EFFBD, with the main difference between the two diagrams being that the EFFBD shows the data stores, triggers, and resources. Remember, the real value of modeling your behavior with an EFFBD is recognized through exercising that model with simulation. For more information and help with the simulator, take a look at the Simulation User Guide, which will also cover resources in greater detail. For more information and resources on Genesys, please visit our website or contact our support team.